Assume x is normally distributed. The average is 11. The standard deviation is 2. Solve ... That means I'm going to ask several questions. Part A, the probability that the random variable big X is greater than little x. Little x is the unknown. That's 95%, I'll say. Okay, so here's a picture of what we have here. I want to find little x such that the area under the curve to the right of that is 95%, you see? So how do I do that using my calculator? I think you see my reflection here on the screen of the calculator. Okay, when I turn it on, you won't see my reflection. Okay, so how do I do that? The inverse norm command. So second, and then dister. Inverse norm, that's choice 3. Okay, so the area in this case, 0.95. The average is 11. Standard deviation 2. Okay, now in this case, I've shaded the right tail. See, the area that I've shaded is to the right of the unknown value that I'm interested in. So I have to use the cursor button. See it down here? Go over to right, highlight it, and press enter. And then press the down arrow to paste, and press enter. And it's giving me the unknown x value, 7.7103. How does that look? So that's the answer, 7.7103. Some of the old TI-84s don't give you the option of tail. It doesn't give you the option left, center, or right. So if you have one of the older calculators, by default, it would be the left. You can only choose left. So if you're using one of the older calculators, what would be the left tail in this case? It would be the area, this white area over here, which is 0.05. So be aware of that if you're using one of the older TI-84 calculators. Okay, now consider this. Okay, can you see me there in the screen? Okay, so the probability that little x is less than big X, which is less than 11. Remember that the big X represents any old x. The little x is a specific x value. So find the probability that any old x is between little x, some specific little x, and 11. That probability is 0.2. So I've drawn a picture here of what we have. Between little x and 11, I want an area of 0.2. See that? Okay, well, the graphing calculator doesn't really have any way of calculating this directly. So what I propose is, what is the area to the left of 11? The total area is 0.5, isn't it? So if this is 0.2, then the little white area here must be 0.3. So I'm going to modify it to look like this. You see, I'm shading the tail to the left of little x such that that area is 0.3. So now I'm equipped to find this in my calculator. Okay, so let me turn it on. Can you see me in the screen? I look like a ghost. Okay, so turn this on. Okay, so go into dister. Can you see this? Okay, choice 3. Okay, so inverse norm. Okay, so the area, 0.3. The average in this case, what is it, 11? Standard deviation 2. Okay, and in this case, it's the left tail. So paste. So 9.9512 approximately. Okay, well, I think maybe you saw it. That's the answer I have here. So that's the unknown x value. How does that look? Okay, now consider this, the probability that big X minus 11 is between little negative x and a positive little x is 80%. Okay, well, this is what we call a compound inequality. So you learned about those when you took intermediate algebra. Okay, so here's the compound inequality. How do I solve that? Add 11 to all three parts, like this. And what do you get? So I can rewrite it like this. I'll say 11 minus little x. 11 minus little x is less than big X, which is less than 11 plus little x. So let me call this, I'll call that x subscript 1. This I'll call x subscript 2. Okay, why am I doing that? What? Okay, I'm going to show this. I'm going to show this like so. Okay, so here I've got the x sub 1 that I just named. Here I've got the x sub 2 that I just named. The area between x sub 1 and x sub 2 is 0.8. So my mission is to find the x sub 1 and x sub 2. Okay, how do I do that? Okay, so I want to find x sub 1. I want to find x sub 2. Okay, so I'll use my calculator. If you don't have a calculator, there's usually an appendix in the back of the statistics book that you can use to find this stuff. But a calculator is much more efficient. So go into Dister. It's inverse norm, choice 3. The area is 0.8. The average is 11. Standard deviation is still 2. Okay, now which do I highlight? Left, center, or right? In this case, I'm talking about the center area being 0.8. So go over to center, highlight it and press enter. Go down to paste, press enter. So I'm getting these two values. Okay, so what are these? Okay, watch this. So x sub 1, I'll say, is 8.437 about. Okay, so 8.437. And what's x sub 2? Can you read it? 13.563. How does that look? On a piece of scratch paper you can carry out more digits if you want, but for the purposes of this video I'm only showing it to 3 places. Okay, so once I get to that point, once I know what my x sub 1 and x sub 2 are, remember what x sub 1 and x sub 2 stand for? Okay, so remember this. X sub 1 was actually 11 minus the original little x that I wanted. X sub 2 was 11 plus the little x that I wanted. Okay, so on the left, I don't want you to see too much. 11 minus x is, I just determined that x sub 1 is 8.437. Solve this for little x, and you get this. So that's my answer, 2.563. Does it work for the x sub 2 value? What was x sub 2? 13.563. So put that in here. 11 plus x is x sub 2. Solve that for x. I'll be darned. You get the same thing. So x is 2.563.